So just make sure you understand, whenever you're dealing with a discriminant, what you're really talking about over here is it's only applicable, as in it only exists if you have a quadratic equation equaling 0. So take a look at something like this. As long as you have something of this particular format, as in a number times x squared plus the number x plus c is equal to 0, because you know by definition that's what a quadratic is. Does this all ring a bell? What I'm saying is, if you have 4x squared plus 3x plus 2 equals to 0, that's an example where the discriminant does exist. So all we're focusing on right now is, how can you tell if the discriminant is even a thing? Like, does it even exist? And if it does exist, when you have a scenario like this, as in this is the scenario that has to come up first. If you don't see something like this, discriminant doesn't exist. If you do see something like this, discriminant does exist, and the discriminant is really just the number in front of the x squared plus number, minus 4 times the number in front of the x times this. So far so good? Yeah? So make sure when you're dealing with whatever the discriminant is something that just you recognize only exists whenever you have a quadratic equation, so something that's a quadratic equaling 0. If you don't have something that looks like this, discriminant doesn't exist. So if you do have something like this, so you have to see something like this first, and then realize discriminant does exist, and discriminant is really just the number in front of the x squared, that's what b squared is, minus 4 times the number in front of the x squared, times this. So pen and paper, you're going to calculate a couple examples of what the discriminant is going to be. And that's why we use the triangle over here. Triangle is just what represents discriminant. So just make sure you know what discriminant even is. It's really just the b squared minus 4ac for a particular quadratic equation equaling 0. You hear something like this, discriminant is just going to be what? You've got to write down clearly what the a, b, and c is first. It just helps with setting this up. So you get a is equal to 1, b is equal to negative 5, c is equal to 6. So b squared minus 4ac is just going to be equal to negative 5 squared minus 4 times this, which is 25 minus 24 equals to 1. Okay, so that's what you're doing over here. Just realizing, hey, this is a scenario where the discriminant does exist, and the discriminant is just the triangle. Triangle over here is just going to be equal to whatever the b squared minus 4ac is for this. Pretty straightforward. Found out it's 1. Just like this, b squared minus 4ac is going to be negative 5 squared minus 4 times 4 times negative 12. Because we wrote first a is equal to 1, you realize b is equal to negative 5. No confusion. C is equal to negative 12. These are called the coefficients, by the way, from basics. So you just understand discriminant is a number that exists over here because it is a quadratic scenario equaling 0. And it's the b squared minus 4ac. b squared, this squared minus 4 times this, times this. Same thing over here, isn't it? Discriminant exists, yes or no? And if it does exist, which it does, it's just going to be the b squared minus 4ac. So you know what the a is, you know what the b is, you know what the c is, and it's just this squared minus 4 times this times this. Whatever number you get from that, that's what the triangle is equal to. This is the discriminant. If you've got something like this, you realize discriminant still does exist because as long as you have a quadratic scenario equaling 0, you have to recognize that this is still a quadratic scenario. This is just an example of a quadratic equation still. 3x squared plus 2, just because there's no x of it doesn't mean the x doesn't exist. What we mean is, technically in front of the x was 0. Point is, make sure you're not confused about why 3x squared plus 2 is still a quadratic expression. And remember, when you have a quadratic expression, when you have something that looks like this, equaling 0, that's when you have a discriminant scenario exist. So this is a scenario where you realize the discriminant does still exist. So just do b squared minus 4ac, a is equal to 3, b is equal to 0, c is equal to 2. So you know the discriminant over here is just going to be 0 squared minus 4 times 3 times 2, which is negative 24. This thing over here, a is equal to 3, b is equal to 0, c is equal to 0. So b squared minus 4ac is just going to be 0 minus 4 times 3. 0 squared minus 4 times 3 times 0. Not confused? Equaling 0. Okay, so these are just all examples where discriminant does exist. It's just the purpose of this is you're looking at this to be able to tell that, hey, this is still an example where the discriminant exists. This is still an example where the discriminant exists. You're learning how to tell absolutely every single time whether or not it's going to even be a thing. It does exist. Just like over here, you realize this is also a scenario where it's still part of this particular format. Does it make sense? This is still a quadratic equaling 0. No confusion? Yeah, like you're not confused about why this is still a quadratic equaling 0, and then therefore a is equal to 3, b is equal to 2, c is just equal to 0 because there was no c over here, and it just means the b squared minus 4ac does indeed still exist. The discriminant does, it's a thing, right? It does exist over here, which is just going to be 2 squared minus 4 times 3 times 0. Take a look at something like this. Discriminant exists, yes or no? This is where you realize there's no such thing as discriminant over here because this is not a particular quadratic format equaling 0. No confusion? Discriminant does not exist in this scenario because it doesn't belong to this format. Okay? This is a scenario where it may look like discriminant doesn't exist because you're thinking about it must be x squared related to x. But this is a scenario where you have to realize, okay, discriminant does indeed still exist. Why? If you're confused, you should be, because you might be thinking a half and then this is 1. This has nothing to do with squared and 1. This is one of the scenarios where, remember the definition from the basics of quadratics? Remember when you're dealing with quadratic equations. Quadratics, there's no rule where it's saying it has to be x and x squared. As long as it's something and something else squared. As long as you have an equation where the variable is just one of the variables over there and another part of the variable is just that squared, you have a quadratic. What we mean is, imagine if you had 3a to the power of 4 plus 2x squared plus 1 equals to 0. That doesn't look like a quadratic, but you'd realize, is the only two variables over here, excuse me, this should be a, are the only two variables over here, a squared, a to the power of 4, are the only two variables over here have an exact square relationship, as in a squared to the power of 2 is exactly a to the power of 4. This is where you'd realize a quadratic definitely can happen. It can be turned into a quadratic. In those scenarios when you can turn something into quadratic even though it doesn't look like one just yet, this is one of the scenarios, isn't it? Because you realize the x and x to the power of a half. Isn't x to the power of a half the same thing as square root of x? So isn't that the same thing as square root of x? 4 times the square root of x plus 3x equals to 0. Do you see how the relationship over here is this is perfectly the square of this? Whenever you have something is the square of that. That's the true definition of a quadratic. So my point is you'll be able to tell this is still going to be a quadratic. And remember what happens in those scenarios. You use a particular letter to represent the smaller power. Let's say, we could say u is equal to x to the power of a half. That means u squared is equal to x. No confusion? Tell me if that makes sense to you. Yeah, this is what I'm point is, you'd have to realize this is still the quadratic equation. Because you can turn it into one. Even though it doesn't look like one right now, you can still turn it into one. As in, it may not look identical to x squared versus x, but you can still turn it into that as long as you realize the only two variables over here have a square relationship. As in, this to the power of 2 gives you this. So you say let u equal the smaller power. U squared is just going to be exactly equal to the other power, isn't it? And you can see you turn this entire thing into 4u plus 3u squared equals to 0. And then you could still calculate the discriminant over here, isn't it? Because who said discriminant has to only be for x? Discriminant is just for any general quadratic scenario, isn't it? A is going to be equal to 3, B is equal to 4. You're not confused about that, right? Same thing as writing 3u squared plus 4u equals to 0. A is 3, B is 4, C is equal to 0, and it's still going to be b squared minus 4ac. 4 squared minus 4 times this is the discriminant for this particular equation, which was transformed from this. Okay, key point. What do we care? We care that, make sure you understand that this is still a particular quadratic example. Discriminant does indeed still exist for this. When you see something like this, you realize, because you're used to the basic examples where it's just a straight up number, it's fully defined, because take a look at the previous examples, you have full on definitions, right? The numbers are fully defined. You get that by the time it gets to this particular example. Do not get confused. You have to realize, hey, discriminant does indeed still exist for this. It's just that the discriminant we calculate, the b squared minus 4ac we calculate from this, it's not necessarily going to be an actual number yet. It's going to be something involving k. See what I mean? Like, just because it doesn't look like a full on equation, doesn't mean discriminant doesn't exist. You can still have something that represents the discriminant. That's going to be a very important skill later on. So you're not confused by why we still do a is equal to k, b is equal to 2 plus k, and c is equal to 3k. Because as long as it's part of a quadratic scenario equaling 0, discriminant still exists. So what we do over here is we can find something that represents the discriminant, which is b squared, 2 plus k squared, minus 4 times, remember bracket is the best way we do the multiplication over here, times k, bracket 3k. Not confused by why this thing, when you expand it and simplify it, is going to represent the discriminant in this particular scenario. Any questions? Just like take a look at this. This looks a bit strange, as in, is it going to be a scenario where the discriminant exists? It might not look like it, but you'd have to realize it does still belong to one that exists, because quadratic by definition, you should have only 1x squared, 1x, and 1c. It looks like you got 2 x's over here, isn't it? This is where it's up to you to realize, hey, this is still going to be a scenario where the discriminant exists, because it's still a quadratic. I just have to make sure that these 2 x's, because I'm aware of, factorization is a technique that can allow me to merge these 2 x's, because check what happens when you merge these 2 x's, kx squared. If you merge these 2 x's, you can say plus x, because factorization, look what they have in common, minus 3k plus 2, plus 3k equals to 0. Now, this looks very strange compared to the typical quadratics, because you have a number in front of the x, not the x in front of the number. Is there any rule why you can't just do kx squared plus bracket 3k plus 2, bracket x like this, plus 3k equals to 0? This is what you need to be practicing. When you go into the exam, you should have awareness about this technique, as in, if you have x factorized into it like this, when you have x factorized into it like this, you know to put it in this, like reverse the order. Because this means x times this. It's the same thing as saying 2 times 3, isn't it the same thing as 3 times 2? You can see why we're allowed to reverse that order up top. And my point is, you see the advantage of reversing it, because once you reverse that order, you now have x squared plus bracket negative 3k plus 2, bracket x plus 3k equals to 0. Do you see that makes it really clear? A is equal to k, b is equal to this, negative 3k plus 2, and c is equal to 3k. See where we're going with this? See how this works? Yep. My point is, you see something like this, right? You realize, hey, discriminant, if I had to calculate it, it definitely still exists. How do I know it still exists? Because it belongs to this. Right now it doesn't look like it. I just make sure that I'm aware that this can still turn into this, which makes it very clear what the b value is. And then I can still find my discriminant because I've got the a, I've got the b, I've got the c. And I do negative 3k plus 2 because b squared, following that instruction, minus 4 times a, bracket k, times c, bracket 3k. And you can tell whatever that is going to be the discriminant, as in something that represents the discriminant. Might not be an actual number, but it's something involving k that represents the discriminant. It's something you need to know how to do. Just like this over here. Is it going to belong to this scenario? Yes, it does, because something times kx squared, something constant. Just because you don't find an actual number that represents the discriminant, you can still find something that will represent the discriminant, right? An algebraic expression involving k that represents the discriminant. This one's going to be easy because a is just equal to k, b is equal to 0, c is equal to 3k. Not confused why these are the coefficients, and just do b squared minus 4ac. So 0 squared minus 4 times k times 3k. Okay, that's going to be whatever the discriminant is. As in whatever that turns out to be, so it's negative 4 times k times 3k, negative 12k squared. Triangle equals to negative 12k squared. See what we did over here? This particular scenario has something that represents the discriminant. Discriminant, you know for a fact, does indeed still exist for this scenario. Get ready, pen and paper. So going to be examples over here, and make sure you find the same answer as these discriminant values. So if you have f of x equal to this, how do you find discriminants? Pause the video, write down what you think the discriminant is going to be, and make sure you end up getting this. Unpause the video, you should get this answer. You should have written in front of you the discriminant for this, which is, you write down first step, a is equal to k, b is equal to negative 2k, positive 2k, c is equal to negative 3, b squared minus 4ac, because triangle is equal to b squared minus 4ac. And the thing that represents the discriminant over here is just going to be, well, b squared, which is 4k squared, minus 4 times k, times c, times negative 3. So that's where you get triangle is equal to 4k squared, minus 4 times k, so minus 4k times minus 3, plus 12k. This is the discriminant for this scenario. As in, if you made this equal to 0, right? The discriminant over there would have been what we found before. Yeah, 4k squared plus 12k. Something like this, discriminant, just means if you were to make this equal to 0, discriminant is just going to be a is k, b is equal to 4k, c is equal to negative 16, b squared minus 4ac. So b squared minus 4 times a times c. And that's going to be equal to 16k squared minus 4 times minus 16, which is positive 64k. Pause, make sure you get this answer, unpause, get this answer. A is equal to k, b is equal to 2k, c is equal to negative 3. B squared minus 4ac is just going to be 4k squared minus 4 times k times minus 3, which is 4k squared plus 12k. Something like this. Does discriminant exist for this? Yes, it does, because you realize, oh shit, there are only two things over here that are involved for the variable. They have an exact square relationship, and discriminant always exists as long as it's a quadratic scenario, isn't it? Because check this out. Once you do 5 square root of x plus 3 minus 2x equals to 0, because you recognize the square relationship. The square relationship is how you can tell whether or not something can be turned, whether or not something can be turned into a quadratic, as in something x squared type of scenario. You can say let u equals to square root of x, let it equal to the smaller power. U squared is then going to be equal to x, and you can see how this entire thing is turned into 5 times u plus 3 minus 2 times x. X squared is u squared is x, excuse me, so it's minus u squared equals to 0. That gives you negative u squared plus 5u plus 3 equals to 0. Make sure your discriminant you calculated it came from a is equal to negative 2, b is equal to 5, c is equal to 3, b squared minus 4ac, b squared minus 4 times this, times this. Confirm that's what you have, yes or no? Something like this, you'd also realize you can definitely turn into a discriminant, because this you recognize can still become a quadratic. Because look at the x squares. You could factorize the x squares like this, couldn't you? 3k plus 2. We just, typically when we factorize, we put the bracket on the right hand side, but it's just for quadratics, it's much more preferable, and it makes life a lot easier if you make the bracket in front, isn't it? Because it clearly tells you what a is equal to. Do you see what we did over here? We see the x has in common with minus 3kx plus 2. We can write the minus 3k plus 2 like this, and the x on the outside, because now it makes it really clear what b is equal to. Do you follow what we're doing over here? As we see this and realize it can be turned into a quadratic, so therefore we turn it into a quadratic, and then once it's turned into a quadratic, only then can we find what the discriminant is going to be equal to. Any questions? You're not confused about how we can turn the bracket over here, put the bracket in front like that? Because what do quadratic equations always look like? They always have the number in front of the x squared, the number in front of the x. Do you see my point? When you factorize, you're going to have a bracket. The bracket can either be on the left or the right. Typically it should be on the right, but in this case we should put it on the left because it makes it really obvious what the a, b, and c values are going to be then. So b squared minus 4 times a times c, and that's going to be the discriminant over here. Whatever that simplifies out to be. I'm sure you can expand this. I'm sure you know how to simplify this. Just like this one, 3kx squared, you realize, or plus 2x squared. Let's put everything on the left-hand side and make it equal to 0 first. Agree that's the most intuitive first step, yes or no? In the next squared, we can simplify like this, 3k plus 2. Read it out to me. What would you simplify the x over here? What would the bracket be here? Say it. We know a is equal to 3k plus 2 then. B is equal to 3k minus 2. C is equal to, what's C equal to? And then you know b squared minus 4ac is just going to be 3k minus 2 squared. Whatever that expanded and simplified is, minus 4 times 3k plus 2 times c. Just like that. Triangle is equal to that.